세 개.
Okay, the first group. Santana. Asla. 14? So not too many, huh?
Yeah.
So you gotta do like 4 groups. There's 14 like 4 groups. The last group. Let's just raise your hands. And I have this. Yeah, this group, raise your hands. Yana Galina? Sentence. Yana Nam? Zating. So let's just start. So let's the last group one.
Johannes Adi Grade analysis. Yeah. This is John.
What is your name?
Adi. Adi.
How you
I choose everything, man.
Almost like a week. Yes. But then you gotta like research. You have to come in here.
I say one number. Didn't I remember? So it's fine.
Alright, okay. We're going to start from the first group. What's your title? No matter who's telling you.
What?
Which did you choose? I think I'm going to So stories are right? Okay. Actually, another story.
So, you know what's in this around?
Greedy
Algorithm. And then binary search.
binary search.
Binary search and algorithm. I told you. We don't mind. Yeah, we looked at the. We didn't do the algorithm. We did algorithm.
Actually, another than that is, you have to make me all that.
Binary search. Binary search.
Binary search?
Serial search. No. Algorithm.
Which algorithm?
Algorithm.
Yeah. Which one?
Greedy.
They chose greedy. They're not taking out. Actually, not the subscriber. You're not up. Sarada? Sabat tahu? Listen up. These two groups will present today. These two, plus yours group, will present tomorrow.
We don't have to search algorithm.
On Friday. Search? Yeah. Search.
What were can she sit down here? No. Wait, that was
that chair over here and then move this aside. Like this. And then she can sit down.
Selezi, Arlet, I expect three groups to present. Three. And then aku, yang ada lima, yang ready to come on. Not touch on this one. Alat lunch off. Doesn't you guys need to? Not touch on Actually, so the first group is in the youngest group. Not touch on the group nacho. Those two. No, you are with him. Like you are. Yeah, just out of you free. Now when it's out of Ela completa. Yeah, so let's see, you got so start your next one. Alright. The first group, you gotta listen. Andy. Now. Ready? Zigan. Next. Leave your stuff there. Just to switch places. Just for this class. Dan what is the other door? I need all of you to see properly. And I need an absolute silence. Good enough? Alright. Your name is who? Who's gonna present it? What is this group? And this is the rule, okay? You have to listen, you have to ask questions. You have to ask questions. Listen? If you listen. Alright.
No.
Let's start.
Yes.
Hello everyone, we're going to present our ICT project and my group members are Dr. Leo and Jonathan.
Binary searching. Number 1. The data must be in order for binary searching to work. Number 2. It takes far less comparisons than serial searching to find an item for your files that have more than a few items in them. Number 3. Binary search algorithms are more complicated to write and understand their serial searching algorithms.
Serial search. The most basic kind of search is the serial search. Criteria are set up before the search begins. The search then starts with the first item and then moves to each item in turn, until either a match is found or it reaches the end of the data with no match found.
Algorithm search. In computer science, a search algorithm is any algorithm which solves a search problem, namely to retrieve an information stored within some data structure or calculated in the search space of problem domain, either with discrete or continuous values. How many search algorithms are there? When to search an element in a given array, there are two
popular algorithms available: linear search and binary search.
Thank you for this.
No.
Yeah.
All right. I'm not done. Do you have any questions? Last one.
Which is the most common kind of search?
Serial search.
Why?
Because it's easy. It's not complicated like binary search.
So binary search is complicated.
Yeah.
So that's all I have. Sorry.
Another question. Another question. Yes.
How does binary search work? Without
No, I'm not. I'm just saying. Without looking.
Yes.
I can't.
I can't. No, the only reason I said that was because I
Different basic question.
Okay, when do you use binary search? How do you use it? Yeah, how do you use it?
You said that.
No, I said what is binary search?
No, you said how does binary search work?
Okay, how do you use it? Yeah.
How does it work? Right? The data must be in order for binary searching to work.
How? What kind of order?
How many steps did you see? Okay, those of you, Andy, those of you who are in classroom, how many steps did we see when we talked about the binary search?
We saw first pass, second pass, and third pass.
That is what? That is bubble.
Yeah, so that's bubble.
That's all.
So wait, for binary search to work, the thing has to be broken in half, like it has to be in two.
Yes.
That's how binary search works.
Right?
Alright, okay, one last question. I'm gonna ask, Lauren, give me an example of serial search. Show us. Show us an example of serial search. Yeah. Take an example. Now, project selection.
Okay,
You're not supposed to
Wait.
copy everything from the internet. Copy everything from the internet.
You can't put an ICT teacher, guys.
Just, yeah, you can.
So,
Alright, wait. The rest of you.
Yeah.
Okay, listen. Especially those who are going to present on Friday. Okay? Project actions to serve. I don't want you guys to copy everything from the internet, bring it here and bring it. No. That's not how it works. Search from the internet, that is good. Okay, that is excellent. Search it. But you gotta come up with an example. Come up with an example. Okay? For example, if you're going to present a binary search, you gotta come up or you gotta figure out an example to explain what binary search is. Okay? So you gotta show us what binary search is there so we can understand it. And also try to bring some points in a piece of paper, not everything. Okay? Points that you want to talk about. Okay? For example, what is binary search? Okay, this binary search is this, and the next point is this. You're not supposed to read it. I can read them. Yes? So next month, especially on Friday, you gotta work like this. I understand. Yes, okay, are you going to give me an example?
yeah. Serial search.
Yes, the main points. All asking about 2 points. You gotta prepare a paper. You gotta prepare that. Listen. Go and say an example. Okay, he's going to give us an example. Continue.
Okay, let's go with Google, for example.
Alright?
Okay, when you search something, you want to search something, for example. You want to search something, you want to search a game or something like that. When you type, let's say this is the type box space. And give me an example.
Who invented the bulb?
Huh?
Who invented the bulb?
multiples.
Yeah, for example, who invented, when you say this, it brings many things. Like who invented the microwave, for example. Who invented the water heater. Who invented the all the things, or the oven, or the refrigerator, or the ice cream, maybe like that. There are lots of criteria. It will bring you lots of criteria. In that state.
Yes. Pretty much simple and great example. Okay? So Takano, I want you guys to bring real example like this so that we can understand what we're talking about. So looking at someone like a banana, you don't get the idea. Alright. Thank you all. Thank you. We can get started. Alright. Very last minute.
Okay, good morning everybody. My name is Edna, and I know Galila's supposed to be the group leader, but she doesn't want to introduce. So this is Sion Sisha, and this is Galila Singh. We're going to be presenting to you about binary search and algorithm. Binary search. Reasonable guess for this round.
Sorry, so that's the business. Yes. 2 meter distance, yes.
Yeah.
Continue, you got like voice reverse.
Okay.
That's
Binary search. Reasonable guess for this round, and let the variable maximum a, x, be the current maximum reasonable guess. The input to the problem is the number and the highest possible number that your opponent is thinking of. We assume that the lowest possible number is 1, but it would be easy to modify the algorithm to take the lowest possible number as second input. Here's a step-by-step description of using binary search to play the guessing game.
Can you demonstrate that? Can you demonstrate using a marker so that we can see?
Right into a square.
You can explain it. You have your phone.
What?
Yeah, you know you can explain it.
Oh, okay. So am I just gonna copy this one? Yeah.
Just right, you say here in step by step process.
Right, step by step. Okay. Then explain. Okay.
You're not like okay, everything is simple things so that you can explain it. Okay?
Okay. Okay, step number 1. Let the minute equals 1 minute. Equals 1 minute, which equals 1 meter. Just say 1 time. No, just this is the first step of binary search. Okay? So let the minimum equals to 1. So then then 1m n or I, which equals to 1. So as it says over here, we assume that the lowest number is 1. Okay? And the maximum, which can be n, m, a, or x, equals to n.
Search it.
Okay, number 2, we have to guess the averages and maximum. It can be A, X, and minimum is I, and rounded down, so it's an integer. So the third step, if you guess the correct number, if you guess a random number and turns out that it's correct, it stops. That means you have reached your search. If the guess is too low, it will be set as a minimum, which is I n.
If they are rounding achieved, I suppose this is only problem.
Oh, jeez. Of course it is. It is. And that's the only time I saw last one. So what should you put out?
Okay, only one already. So for the fifth step, if the guess is higher than the number, that means it's set as maximum, which is either A or X. And it's programmed not to be smaller than the guess. And the final step, which is step 6, is simply go back to step 2. You can make a description even more precise by clearly describing the inputs and outputs of the algorithm by clarifying what we mean by instructions, like guess a number and stop. But this is enough detail for now. Next up, we'll see how we can use binary search on an array and discuss how to turn descriptions of algorithm into actual working codes. You could hear
Okay. I'm going to be reading about algorithm. So in computer science, a search algorithm is any algorithm which solves the search problem mainly to retrieve information stored within some data structure of calculated in search space of a problem domain, either with discrete or continuous value. Specific applications of search algorithms include problems in combinatorial optimization, such as the vehicle routing problem, a form of shortest path problem. The knapsack problem given a set of items which with a weight of a value determine the number of each time to include in a collection so that the total weight is less than or equal to given limits and the total value is as large as possible. The nurse scheduling problem. Problems in concentrate satisfaction such as the map coloring problem, filling in a Sudoku or crossword puzzle. So these are the nursing schedule problems. Like I said, they are like this filling in the Sudoku or like filling in the crossword puzzle. So algorithm is something that has it has its own nursing problems that have these type of problems, and they include things like I said before, crossword puzzles. In game theory, and especially combinatorially game theory, choose the best move to make next, such as the minimax algorithm, finding a combination or password from the whole set of possibilities. So what you do is, for game theories, you find combinations and passwords that you can fill in order to play the game. So factoring an integer in brackets, an important problem in cytography. Okay, optimizing an industrial process such as chemical reaction by changing the parameters of the process, like temperature, pressure, and speed. So what I told you right now is the steps of how to use algorithm and what you need in order to know how to use algorithm. The classic search problem described above, the web search are both problem and information retrieval, but are generally studied as separate subfields, are solved to evaluated differently. So they're evaluated differently because the web search and the informational retrieval aren't the same.
Algorithms are often evaluated by function of complexity or maximum theoretical runtime. Binary search functions, for example, has a maximum complexity of O log n or logarithmic time. This means that the maximum number of operations needed to find each target are logarithmic functions of the size of each search. Algorithms for searching virtual spaces are used in constant satisfaction problems, where the goal is to find a set of values assigned to a certain variable that will satisfy statistical math equations and inequations equalities. They are also used when the goal is to find a variable assignment that will maximize and minimize the certain function of those variables. Algorithms for this problem
include the basic brute force search, also called NAVY, or uniform search, and a variety of first donors that try to explore particular knowledge about the structure of the space, such as linear relaxation, contract generations, and consistence of quota bonus. An important subclass are the local search methods that view the elements of the search space as the vertical of a graph, with edges defined by a set of applicable to the case, and scans to space by moving from item and long edge. For example, according to the steepest distance or justified circulation or the stochastic search, this category includes a very great variety of general meta-heuristics methods such as simulated annealing, tableau search, A-team, and genetics programming. The combine a variety heuristics in specific ways. This class also includes various tree-search algorithms that view an element as a vertex of a tree and establishes that the tree is some special order. Example to the latter included an explicit methods such as depth-first search and breadth-first search, as well as various heuristics-based search tree-pairing methods such as backtracking and branch and bond, unlike general meta-heuristics, which at the best break only in probabilistic senses. Many of these tree-search methods are guaranteed to find the exact optimal solution. If given enough time, this is called complex tenses. Another important subclass consists of algorithms for explaining the game tree or multiple player games. The statistics are graphed among those nodes consist of situations that can result from the current situation. The goal in this problem is to find the move that provides the best chance of a win, taking into account all possible moves for our opponent. Similar problems occur when human and machines have to make successive problems occur when humans or machines have to make whose outcome is not inherently under one's control, such as the robot violence or marketing, financial or military strategy planning. The kind of problems combinatory research has been extensively studied in the context of artificial intelligence. Examples of algorithms for the class are the minimized algorithm, alpha beta, pairing, and the A algorithm and its variety.
Okay, wait. Hold on.
ላጥፋው ሚስተር ታስረዳለህ ወይ ላጥፋው ታስረዳለህ ላጥፋው በራስ አትችላለህ